accordingly to requirement of water requirement will be different. Otherwise you have to add an admixture. So these things, this is a standard sand and this is your ferrochrome slag. So I came to another one. So I am not going because this is not a particular research, so I am not going deep to a particular research, but I am just throwing out the different aspects of it. I came to another point called control low strength material. We are talking about high strength concrete 40, 50 MPa. Here I am talking about maximum 8.3 or within 20 MPa, that strength. This material nowadays is very essential, particularly for development in metro areas. This methodology old since 1960s in USA. What happened? Because we as a Indian were in very comfort zone. We have no restriction. But in other places they have got lots of restriction. So they are forced to think innovatively. Like today we have got a place here, we know we don't like it, we spread horizontally in the other direction. But there the land is restricted, you have to work in that. It was interesting to see in Hong Kong, it is written there. Initially Polaris, it was 4-storied, then they made it 16-storied from 18th century. Now it has come up to some 70 century. But the place is 70-storied because the place is same. They have to go only vertically up. So that's why during one construction of a canal, they were not asked to dump your material anywhere. So they have to use that material nearby. So that is how came this material called control low strength material. Now people are using different material in this control low strength material. So no need to tell, as a concrete material, it is a control low strength material similar to that of flowable concrete or self-compacting concrete. You might have seen where on the road most of the cracks develop near the culverts because your roller cannot come close to the culvert. That is not properly compacted. Today there are during infrastructure development, you see they make a trench, put the pipeline, then put the sand in it. After one rainfall, you will see there is a depression. Then they will put some concrete also that gets cracked and compact. It gets depressed. So these are the places where they first try to use this flowable concrete. Instead of I will say control low strength material. The name should be exactly, we should honor it, that is CLSM. It is just similar to your self-compacting or flowable concrete. There it's no need of compaction, no vibration. You have to just put the amount of water, cementitious material in a proportion so that it gets hard or becomes hard within a stipulated time. Evening you have to work, next day morning traffic may run. So in such cases, this is also being used. So there, as usual, you need to see its properties: fresh state, hardened state. Then one more thing here I add it. I said this material should not be problem to the environment. Many times the use of this industrial waste is restrained due to the leachate problem. There is a place called Sukinda in Odisha. It is there in everywhere. There is a Nala which is infamous, even in UNO also, even WHO also it is there. That is chromium. Chromium is very hazardous to human health, and that is the problem in nearby Nala they have found out, because there are chromium mines is there. So from that mines through leachate, because there are two types of chromium, trivalent and hexavalent chromium. So one of it is very dangerous. So all they have now any water, even the rainwater comes out of that mining area, they treat it, then only leave it to the ground. So that is one of the important, like mining or industrial waste. That's why now saying zero discharge. It should not give any leachate or residue to the environment or nearby water bodies. So that is another aspect you have to check it. Then microstructures. So these are some of the study you need to do for a control low strength material. So for that ferrochrome slag, we have used cement, and these are in different proportion. Another aspect, I said fly ash are spherical. What is the problem? We could not get the strength. With of no friction, so my retaining wall, there was a delay. I mean shifting. But what is the advantage? Pardon? Yes. That's why I called it mineral admixture. Fly ash is mineral admixture. So it helps in, so many places we are using this fly ash. Lubricants, like a spherical one, can easily move. So that is the advantage of it. That's why called as mineral admixture. So that in all this control low strength material, we use that fly ash. The basic, all those what may be the basic material, we try to use fly ash. Because I said self-compacting, it's flowable fill. So that fly ash helps me in that. So these are some of the very rudimentary tests we do. One we call it as a flow, other is a bleeding. In self-compacting concrete, because many of you are from that concrete background, how you measure that whether it is a flowable or not? Through the flow diameter, and other equipments are also there, segregation and so on, B test. So now, so similar test also, because when you see concrete, obviously we think of high value. When I am saying low strength, we have to take about 3 low value. So obviously I may not use that sophisticated equipments, but these are some of the equipments I can use it. One I am saying flow, other is I am segregation. In concrete, segregation means water should not be the particles, what should not be out. How we are measuring? So this we are measuring our hydrometer, that one jar, cylindrical jar, and at the top whether we are checking whether any water is there. That means they are segregating. That is, we are saying it as a bleeding. So that also, based on that, we have plotted and see, depending upon the flow value, it is high flowable, medium flowable and low flowable. Accordingly, where you want to use it, that you can use. These are the compressive strength, 7 day, 28 day and 56 days. Then these are the severe value, very high severe value we got. And then microstructure, obviously as part of research, it's not only this. Now you have got the accessibility of same ADX and SCRD, so you can go for it and see. They are saying these are your CSS gel or that is responsible for gain in strength. And there is another thing, what I said, in your trench, you are dumping something, after some time it is settling. So for that you have to do a small test called settlement test. 7 days, 28 days, 56 days. Some of the fill, there was no settlement and others has settlement up to 1 millimeter. That also you need to study to say whether I will be able to use it or there or not. Okay, this is another case where you can use your industrial waste in huge quantities. As I said, if you use only fly ash, then you have to cover it. I will come to that. So if you are using as a low strength material, you can directly use it. Around 20 to 30% of fly ash we can use it here, and other industrial waste, that is a raw material, with cement percent varies up to 8%. So this is what I say, leachate. You have to go for heavy metals, that should be within limit. If that is not within limit, then you have to do some other techniques. I mean, some admixture you have to do, go for it, or you have to make some amendments. So accordingly you have to reduce it, because that should be within permissibility, otherwise it's not sustainable. Then another one we try to use using coal mine overburden. Because I was showing my first diagram, I was in a mining area. So there I have just finished their problem, then came with some material. So to use it indifferently for my research, for the student will get the benefit of it. So there Similarly, we did everything. There is one more thing here we add it. Today morning there was a discussion on this cylindrical sample and cube sample. So as a low strength material, mostly we try to use this cylindrical sample. So this is called slag durability test. Actually, I will show you this because it was misplaced, some other place it is there. We are now saying, because we want a high performance, because durability, like today morning he was saying, we are also going through IS 456 1978. When only it came 2000, there was a term called durability. Otherwise, before that, there was no durability term. In one of the construction, because I am saying sometimes I am taking you there, as a construction, once we are constructing water treatment plant, we added the best cement available locally, put the admixture. Water treatment plant means it was M30 minimum. But after 24 hours we found, well, remove the cube, there are some cracks from both the sides. It is not properly getting set. I was out of station, so I informed the engineer, said that you break that roof. But it's not that easy. So obviously it is in a government building, it's not that easy. So I did December, then I came back from vacation, I found still it is there. So obviously before breaking, contractor will say that we have to go for investigation. We took the cube. The strength was coming around 17 point something. So if like 1.25 cube strength is 1.25 cylindrical cube, and for the core you get cylindrical sample. So he said it's coming 20 M20, something like close to M20 but less than that. And it was not directly retaining the water, it was the roof of the filter house. So obviously, should we keep it or we should dismantle it? So strength satisfied, it's fine, or we should go for durability. Why it is more stringent in water treatment plant or water retaining structure, not in other places. So after lots of deliberation, argument, we say no, durability is also an important aspect. We have to redo the same thing after breaking it. So durability nowadays is very important, not only the strength. So keeping that in mind, there is one type of durability called slag durability test. I was not knowing what is this slag durability test. How many of you know slag durability test? Because here mining engineering department is there, so might be one equipment. Otherwise in civil engineering department nowhere it is. Why it came to my once in one place, the bridge, the pier failed. They say everything was fine, but the rock beneath it had some problem, it is eroded and they disintegrated, so it's collapsed. And how we can measure that? As I said, I am also technical committee member of Indian Road Congress for the foundation engineering. So there I came to know, they said how it is possible. Then I came to know mining engineering department, there is a called slag durability index. I'll say some of the durability test. So there we put it in a drum. Let me go for there. I think it is there. I have got it. Okay, so maybe I have to be fast. So this is the test equipment. Very rough, rudimentary. But there my sample will be here inside this drum, which has got this jelly like cover. In the presence of water, it will rotate. So as it is rotating, this is scraping my sample in presence of water. So obviously its durability is best checked. So that is what, if you are using that, so obviously if that it passes that test, it is more durable than other durability test you might have done freeze, thaw, alternate wetting and drying, and all this we have tried also, but this I said, so obviously, and again after taking it out you have to put in the oven, it becomes full dry for 10 hours, again you bring it and put in the water and rotate it for half an hour. So this makes the sample very tough in terms of durability. So that also we did the testing. So I am not going for very what I will say, costly testing. So these are equipments might be available in some places where I said the mining is there. So after 3 cycles, the see the shape of the aggregates were like this. Now it has become very smooth. And based on that, they called a factor called slag durability index. And that slag durability index, based on that, for different type of rock, a classification is there. Based on that, you can say how much durability is. So, because my material, if I feel it is strong, and if I can use it like a rock material, so then I can go for it. So, another thing nowadays, some of might be using, that is biopolymer, bioremediation. In fact, this sustainable geomaterial or sustainable material, last year I was in Egypt, they were saying that some people are saying that pyramid is also built using some techniques, what we are now saying it as alkali activated material. So that they were using some techniques that time to prepare it. So here another sustainable things is called biopolymer or bioremediation. Even last week I had gone to see one of my dentist, is related to me. He said I will use bioceramic. When everywhere now we are saying like geopolymer, what you are saying, another is also coming biopolymer. So that is another aspect. Recently one of my student, he worked on it, because inspiration was, I'll come to red mud, I should have done it first. So I was working on red mud. I told my student to go and work on it. He said it's not, sir, workable. The pH is 11. His hand was becoming almost whitish. Then I remember I came from village background, so I said, put some earthworms in it. Earthworms, I know that any earth they will take, they will make it a fertile, something different. So he put some earthworms also. It's not, it is nothing to do with civil engineering. But I said if you are not able to use it, put that, they will change it and you can use that. They all died. After 7 days he said no earthworm is present inside sample. So I said then you talk to some agronomist. He has a friend in agriculture university, he said it's at a high pH, even you see, even these natural, those microbials also will not survive. That's why they said if you are having a alumina plant, red mud, permanently kills all the vegetation there. I was not knowing that, because I was trying in this way that my students should feel comfortable to work. Then after what I did, I tried to get a bacteria from NICM, that they say they used to put lots of culture, these microbes. So I asked for them, they said it can survive in high pH. In fact it survived. And then it changed the pH, then it became workable, we could work. So that is how sometimes you have to think differently when it is required, because we have no choice, we are facing the difficulty, how to work it. And obviously people will say, if you are doing differently, you will be, criticized, you are doing something out of the way. That means one of my colleagues said to my student, if the gold helps in for this, that means your guide will put the gold in it. That means that may be you have to learn. Actually, but I tried just to see whether it is possible. And then we say, soil, can it be, so this is our ASC paper, can we think of as soil as a 4-phase system? We propose they are not as a 3-phase system, suppose it is a 4-phase system. Microbial 4-phase system, why you say? We say in soil as 3-phase system we have got soil, solid, water and air. Then we say air has no weight but it has volume. We said say microbial has no weight, no volume, but there is a presence. Because what is changing? It may not be changing your density, it may not be changing your OMC MDD, but it may be changing your thermal properties. It may be changing your electrical properties. That is what we did. We try to measure that and then propose that can we think of this microbial is another phase in soil. So based on that we said these common geotechnical properties are not changing, but some of the other geotechnical properties are changing. like your thermal properties, electrical properties, and that is nowadays required. We are saying lots of atomic power, but this atomic waste, fly ash we are wasting, dumping at the ash pond. But you know where you have to dump our atomic waste? Maybe 1,000 meters below. And that soil, they are put in a canister, I mean the box, that is with bentonite soil. It should be impermeable. So many things are there. And that temperature, if there is cracks happens. So all these things, now there also people are geomaterial who are using, thinking of to manage, that is also an industrial waste. Then how to arrest it? So there, this thermal and electrical properties is important in such cases. So if microbial presence will help it. So then one student became successful because he was adding very small things and getting the properties only thermal and electrical. But suppose you are interested for some other properties like liquid limit, plastic limit, you need more samples. So for that, we try to culture one bacteria called Xanthanum campestris. That was a difficult term, but they say it produces xanthan gum and it is available in the market. So obviously we have no time to make a culture because we have got fortunate to have a life science department. So there it was, we are making the culture and getting lots of bacteria, I mean that polymer. So then we added two biopolymer, one is called xanthan gum and guar gum. Where I tried to use it, I was showing this diagram. There's a dust problem there. And these are the places they dump. I could not show you another diagram, another picture. Another truck is coming, it has got the water drums.